Okay, thank you, Terry.
Thank you. Hi, everyone. The South History Museum and Hamptons Observatory. How many of you have come to events for the Hamptons Observatory before? Okay, just a few of you. So then, to the rest of you, I'm going to talk about what we do and how we do it. I'm Terry Beanstalk. I'm the president of the group and one of the original founders. This was a labor of love, starting with Jay Schneiderman. For those who know Jay, he's now the Southampton county supervisor. Jay was a science teacher many moons ago. Had this idea of bringing a telescope, a professional grade telescope, in the east end of Long Island because we have some of the darkest and clearest skies in the United States. And started the process, couldn't get funding from the county, and reached out to the public, gave it a friend of mine, and thought that we could do this without public funding. So we created the group. I'm dating myself, maybe 18 years ago, with the idea of buying a professional grade telescope, building an observatory, making it available to the public for free, and having events year round. And eventually we started just during the summer, but we wanted to do year round, to have lectures, star parties, and planetarium shows. So we bought all the necessary equipment. We ultimately acquired a revolutionary, state-of-the-art professional grade telescope. We have the largest professional grade telescope on Long Island. It's housed in our observatory at the law school, and we can use it directly and remotely. And started having monthly events year-round, lectures with science writers, astronomers, professors. We became affiliated with the Museum of Natural History in New York. They would provide lectures. We did everything live, and we decided to have it throughout the South Fork. So we would rotate our lectures between Montauk, Amagansett, East Hampton, Sag Harbor, and Southampton, which we still do. And but we found some homes like here where we do regular lectures that are sort of centrally located. And great. And we run out star parties, both with and without lectures. And we have a portable planetarium. We do planetarium shows for kids. The idea was science education for all ages and without any charge. Say that again. We charge nothing to any member of the public for anything we do. How do we do that? Well, obviously, it costs money to do all of that. And so we have donors who help, small amounts, medium amounts, and large amounts. Large amounts are the most helpful, obviously. But we could certainly always use help if we want to keep all of this free. So, Hamptons, we used to be called the Montauk Observatory because we were physically based at the Teddy Roosevelt Park, which is now the Montauk County Park. We were physically there. When we moved to the law school, when we built our observatory, we decided to use a more centrally located name, so we changed it to Hamptons Observatory. HamptonsObservatory.org is our group. Registration on it is free, and you'll get all of the notifications of these events, and as well as links to all the YouTube videos of all the lectures. Last month we had a lecture from one of the top attorneys from NASA, who is in charge of the International Space Station, as well as a whole host of other things at NASA, who's also married, a friend of mine, is married to the commander of the International Space Station. And he came here right before COVID, lectured in person. We held that at Guildhall. We had separate lectures for adults, and then we had a separate one for kids. Those were the most widely attended lectures that Guildhall has ever had in their entire existence. So there's interest in this, enormous amount of interest. And we just need people to come and enjoy it and hopefully participate. With that, William Taylor has been working with us for a long time. I'm not sure exactly how many years, but it's probably close to 10 years. He's our senior educator for the Hamptons Observatory. He's exact name, but I always forget the details. He is the NASA JPL Solar System Ambassador for the last decade. The professional astronomer and a great guy, and he's done a lot of these programs for us. And with that, I'll turn it over to you.
Thank you all for coming tonight. Thank you so much to the Southport Natural History Museum for making this event possible by hosting us. And thanks again to everyone who's helped out with the observatory over the years through any kind of form of donations, volunteering. It's been really appreciated, and it allows us to keep doing this for you because I see a lot of familiar faces, see a lot of new faces. So it's always exciting when I do these to see who's going to come. We feel like we know the whole community of astronomy buffs out here on Long Island, but there's always more. So it's exciting when you guys come. So the theme tonight is just called Summer Stargazing. It was pretty general, and at the beginning of when we're planning this, I didn't really know what was going to be going on this summer because there wasn't anything scheduled big. but as it turns out, some big things are happening. So if we could go to the next slide. Okay, so what's up in the night sky? Well, let's see. So the next big thing is probably going to be a nova, an exploding star. I can't guarantee when this is going to happen. I know nobody knows for sure, but a lot of astronomers believe that we are going to be getting a nova, which means a new star. It will last just a few days, so it's really important to keep your eyes on the news if you're interested in seeing it, because you'll have about a week to see it once it comes, and I'll tell you all about it. If we go to the next slide. Yeah, so this year has been a big year so far in astronomy. We had the total solar eclipse in April, a spectacular event that a lot of us got to see. We also had in May a spectacular surprise of auroras all over the world, and even in tropical places like Florida. Here. All right, technical difficulties. All right. Okay. Okay, great. So if you got to see, if you got to see the auroras, I'm happy for you. I didn't get to see them because it depends on where you were at the time, and where I was at the time. It was pretty cloudy, so that's what happens in astronomy. We have another okay. Let's see. I'm gonna. You guys hear me now? Yeah. Okay, great. So let's go to the next one. So this is what I call the spectacular ordinary in summer. We get used to things that happen all the time in astronomy or the natural world that are really amazing if you think about it. Here is a view from Fire Island. So you can see the same view here on the east side of Long Island of the entire central part of the Milky Way rising over the ocean. I think it's the most beautiful thing you can see in the summertime. And if we go out late at night tonight or anytime during the summer, there's no light pollution in the ocean. The ocean is free of suburbia. So you can see really, really far in that direction. And when we look to the south here, we look straight into the heart of the Milky Way galaxy. So we live inside of a galaxy, we can't always see the shape because we live in a big flat disk, but that's what we're seeing every night in the summer. It's the most spectacular thing. I'll be talking about that again. The special thing that's happening this summer, which is kind of new and unexpected, is a new star that could be coming. And it could be coming tomorrow night, it could be coming tonight, it could be coming by September. No one really knows exactly when. But it's this star called T Coronae Borealis, also known as the Blaze Star. And this is a variable star, which means that it changes its brightness intensely over the course of time. So normally this star is in the 10th magnitude. In astronomy, when you say something has a high magnitude, like 10th magnitude, that means it's very, very faint. 10th magnitude is something you can barely see with binoculars. It's something you could pretty easily see with the telescope, but most of the time you can definitely not see with your naked eye. Over the course of the nova that we expect, it'll go up to the second magnitude, which is among the brightest stars. So the North Star is second magnitude. And I'll show you some other stars nearby that are that bright. So basically it'll seem like out of the darkness of space, a new star has arisen. However, it's not brand new, because it is part of, it's a recurring nova, which means that about every 80 years, the star blows its top. So we saw this happen in 1946. It also happened in the 19th century. And for all we know, it's happened for billions of years previously, but that's when we started to notice it. So it hasn't erupted since 1946. So astronomers are really interested in watching the star all the time. There are people who call themselves amateur variable star observers, who do this as a hobby. And according to Leslie Peltier, who is one of the greatest of all observers of the night sky, he once said, let's get this quote, "I feel it is my duty to warn others that they approach the observing of variable stars with the utmost caution. It is easy to become an addict. And as usual, the longer the indulgence is continued, the more difficult it becomes to make a clean break and go back to normal life." So what does a variable star observer do? Now, most of these people who do this are what we call amateurs. They're not professional astronomers. They're not getting a salary for anyone to do this. And the reason that most of our knowledge of variable stars comes from these amateur people is because it's very difficult for a professional astronomer with all the obligations you have to do research projects or particular things, to go out and just look at the night sky every night and count what stars are brighter than other stars. So the American Association of Variable Star Observers is an organization that anyone can join, anyone can contribute to, and you can be the first person to notice when this star blows its top again. You could be the one. Every time something like this happens, someone is the first person to see. You might think that there is like the Hubble Space Telescope observing, but the Hubble Space Telescope does not have time to observe everything like this. So this is something that some amateur observer in the world will be the first person to notice, and it could be you. So that's why I recommend you go out and do it. Unfortunately, for Leslie Peltier, he went out every single night for most of his life to observe the star every time it's the night sky for about 25 years. On the actual night it happened, he had a little bit of a problem. For more than 25 years, I looked on it from night to night as I tossed and turned in fitful slumber. Then one night in February 1946, it stirred, slowly opened its eyes, and quickly drew aside the draperies of its couch and rose. Full 80 years had passed since last that star had shattered the symmetry of the northern crown. And where was I, its self-appointed guardian of that once in a lifetime night when it awoke? I was asleep. I had set the alarm for 2:30 a.m. intended to get up and observe some early morning variables. The alarm clock did its part. I looked out the window and the stars were clear and bright, but apparently I was not, for I sneezed once or twice, got the feeling I was coming down with a cold, maybe even worse. Self-pity comes easy at 2:30 on a cold February morning, so I went back to my warm bed with the comforting thought that I owed it to my family, at least, to take care of my health. Thus, I missed the sight of the night of night in the light of T. Coronae. It was a night of spectroscopy has longed for. It is in those earliest hours of awakening that the newborn star, with all the exuberance of youth, divulges its most intimate secrets. And he goes on to say, he still watches it, but now with a wary eye, there is no warmth between us anymore. So if we go to the next slide. So this is what happened in 1946. The star, which is usually at magnitude, became a little bit brighter for a while in 1944. Suddenly it dipped in 1945. May 1945, so around the DE Day, there's a lot going on in the world besides variable star observing. But at the end of 1945 and the beginning of 1946, it suddenly skyrocketed up to really high, bright magnitude. And if you go, you can see the next slide. Yeah, here we go. Here is what is going on now, though. So the two different colors, the top represents what's called the visual magnitude, which is what you can see in terms of how bright it is. You can, an observer, anyone can learn to train themselves to measure like pretty precisely how bright a particular star is. And so the blue one just represents how bright it is in the blue spectrum. So stars, we want to look at particular spectrums for more information. In both spectrums, the star has suddenly started to decline. around the beginning of 2023. And based on the pattern that we have from 1946, we think that it has about a year from the beginning of the decline until it explodes. And so we're coming up this summer on about a year period since the beginning of the decline. And so that's why observers are thinking, that's why astronomers are thinking that we're going to be getting the nova soon. It's not clockwork, it's not guaranteed, but it seems likely. If we go to the next one, you can see what is causing these explosions. So when we, T Coronae Borealis is actually two stars. One is a red giant, and the other is a white dwarf. So I'll explain what both of those are in a moment, but basically, the white dwarf is extremely dense and very small, and it's suctioning off the immense gas of the red giant, and that spirals down to the surface of the white dwarf. But the white dwarf only handles so much matter on its surface before it ignites and explodes again, the nova. And that is what causes the eruptions that we see every 80 years. There are a lot of other stars like this in the universe. And most of the nova that we see, which is just Latin for a new star, are caused by this type of phenomena where a white dwarf is stealing matter and then igniting once it reaches a certain magnitude. More familiar to a lot of people might be the supernovas that you hear about. That's when a red giant star, reaches the very end of its life and completely explodes. We haven't had one of those in the Milky Way galaxy since 1600. So if we had one of those again, it would be an extremely bright star. It would be the brightest star in the night sky. T Coronae Borealis, when it explodes, is not going to be the brightest star in the night sky. It's going to be one of the brighter stars. But I think that the excitement of it won't be that we have a really bright star in the sky, but it'll be that we have a new star. So what I recommend everyone who wants to appreciate this is try to get familiar with the way the constellation that it belongs to, which is called the Northern Crown, normally looks like. It normally is a very beautiful symmetrical crown shape. So when it gets an extra star, it'll be unusual and be very recognizable if you become familiar with the normal shape first. Okay, if we go to the next one. Red giant. Let me try to frame that for all of us. In the picture, you can see what the sun looks like, little circle there, right? And some other stars that are similar in size and brightness to the sun. As the sun ages, nothing much happens until it gets to be about 10 billion years old, and then it slowly starts to expand. And the current thinking is that when the sun reaches the very end of its life, it's going to expand into something called a red giant, which is the enormous star in the ray. It's not going to weigh anymore, it's not going to have any more mass, it's just going to be much bigger and much less dense, so it's going to keep expanding like a balloon. And unfortunately, it will probably swallow most of the planets in the inner solar system, including our own. So if we go to the next slide, you can see how much the sun already massively is larger than the Earth that we live on, right? So here's a picture of a solar flare, which some of you might have seen during the last eclipse in April. There are solar flares all the time that cause auroras. Most of these solar flares are larger than the Earth. So when we get the other type of star in T Coronae Borealis, which is called the white dwarf, what happens is that that's a star like our sun, which has gone through the red giant phase, it's expanded out as much as it can possibly do. It has used up all of its nuclear fuel, so it has no more hydrogen, no more helium left to turn into anything else. And it starts to collapse in on itself. And it collapses until the star, like our sun in this case, turns into something the size of the Earth, right? So imagine something as huge and massive as the sun shrinking to the size of the Earth. It becomes extremely dense, and the only reason it doesn't collapse any further is that something called electron degeneracy, I think, right? So what this means is that electrons don't like to be in the same place as other electrons, right? There's a fundamental facet of quantum mechanics that says two particles want to be in different places. So if you squeeze all the matter in the sun into something much tinier than the Earth, the electrons are going to be protesting like crazy, and they're not going to want to be squeezed any further. The only way you can get them squeezed any further is if you had a huge gravitational force of a star much, much bigger than the sun. That can cause a black hole or a neutron star. Our sun is not that big, most stars in the universe are not that big, so it ends up like a white dwarf. If you go to the next slide, a white dwarf is very faint compared to the original star because it's very small, right? It's shrunk from something the size of the sun to something the size of the Earth, but it's still very hot, right? Because it's still an immensely heated not even gas anymore. It's a weird form of matter we don't have on Earth. It's extremely dense. And in that form, the kind of zombie star can last for billions of years into the future. No one knows how long. Longer than the universe has existed so far. The closest one to Earth is called Sirius B. Sirius A is much more famous because it's a very large star and it's the brightest star in the night sky. If you go out in the winter time, you can see it easily. If you have a very powerful telescope and you're lucky, you can see Sirius B next to it. It orbits around Sirius A. And it's a very, very tiny star in comparison. Okay, the next is all about Saturn and the other planets. So Saturn is usually the most exciting thing when I go out with people looking at the night sky, because it is the most beautiful planet. I would like to show you Saturn tonight, but it's not going to be rising until way after midnight. But I want to talk to you about Saturn because it's definitely the best planet of the summer. So here's a picture of Damien Peach. She's a great astronomer who lives in the UK. And it shows you what Saturn looks like nowadays. Saturn is getting really, really close to the part of its orbit where we are looking at its rings edge on. And the rings seem to disappear from our point of view. We're not there yet, but the rings are really narrow. So when you go out this summer and look at Saturn, instead of seeing the big, beautiful rings that you normally see, they're still there, but it looks almost like a spike going through the planet. And you can see also the shadows that it casts on the planet itself. So if we go to the next slide, here we can see where to find Saturn. So this is the view tomorrow morning. So if you get up before dawn, you can see a lot of the planets in the night sky. Saturn will be fairly close to the moon in the constellation Aquarius, which is where it will stay most of the summer. We can also see the planet Mars if you go out early in the morning, so 4 o'clock. If we go to the next one, if we zoom in on the moon, if you have a pair of binoculars, you can also see another gas planet, Neptune. Right? Neptune is really hard to see because it's very far from us. It's very large, but it's very far. However, if you have a regular size binoculars, you can see it. You just have to know where it is. And this morning at 4 o'clock in the morning or whatever, you get up before dawn. It's a good opportunity because the moon will be passing very close to them. So if you can use the moon as a guide, it'll be something like a star very close to the moon. We go to the next one. We're also this time of year we're getting an alignment of most of the planets in the solar system in the early mornings. So in addition to Saturn and Neptune, you can also see Mars, Uranus, and Jupiter. And all those planets are going to be easier and easier to see as you go through the summer and into the fall. But as of right now, they're all early morning objects. So since there are no planets to see this evening, I'm going to be talking about some other objects you can see throughout the summer. There's one called the Dumbbell Nebula, which I hope you can all see. That is what is called a planetary nebula. So you can see where it gets its name. It looks up like a dumbbell you might lift up in the gym, right? Its formal name is Messier 27. And it's what's called a planetary nebula, which is a bit of a misnomer. It has nothing to do with planets, really. Really what it is it is a star like our sun that has exploded. It has come to the end of its life. Our star will form a planetary nebula like this one day. The reason they're called planetary nebulas is because if you're looking through them, looking through a telescope, you might accidentally think they look like a planet because they have a disk. Most things in space, when you look at them, are just points of light, most stars are. So they stand out. But this is the really big one. So it's 1,360 light years away. So as most of you know, light takes a certain amount of time to travel. It takes 8 minutes to come from our sun, and our sun is pretty far away. It takes about 24 hours to cross the whole solar system, but it takes 1,360 years to travel from the Dumbbell Nebula. So when we look at that light, we are seeing light that emerged in the year 664 AD. There was a famous astronomer from India named Brahma Gupta who died that year. So when you look at stars and you look at things in the space, you are looking backwards in time. If we go to the next one, here is a view of what it looks like through a telescope. I'm not sure everyone has a different impression of it, but it looks like a little pink smudge, and I think it's one of the brighter and more compelling objects to look at in the summer sky. If you go to the next one, you can see another planetary nebula. Oh, sorry, this is where it is. So it's close to a really huge constellation called Sagitta, which is a Latin word that means narrow. So a lot of constellations don't look like what they advertise to look like, but I think the arrow is a constellation that really does look like an arrow. Right above it is the constellation Cygnus, which means the swan, which is also a really beautiful constellation that does look like a swan. So, and it's also not that far from the dolphin below it. So summer has a lot of constellations that are really nice stick figures that really do look like what they're supposed to look like. And part of astronomy is just about learning these constellations so we can find them faster. If we go to the next slide, we can talk about the Ring Nebula and the one after that. So the Ring Nebula is also a planetary nebula. So this is a star like the sun that has exploded, that has given off most of its gas as a giant ball of expanding hydrogen. This one is 2,567 kilometers per year. So the light from this particular nebula left on its path to Earth when Cyrus the Great was ascending the throne of Persia a long time ago. If we want to find it through a telescope, it doesn't have the bright colors you see when you look through the Hubble pictures, right? It looks faint gray. The eye is not so good at picking out really distinct colors in space, but it looks like a little ring, which is why it's called the Ring Nebula. It's very beautiful. It's very small, so hopefully we can see that tonight. It's part of a really lovely constellation called Lyra, which means the lyre, but it looks more like just a parallelogram, right? But if you know, you can identify the two stars at the bottom, Chiliac and Sulapat, and you can find the Ring Nebula right between them. So the next object I want to talk about is one of the highlights of the summer sky. It's called the Sagittarius star cloud. And this is what I think is the glory of the summer when we do stargazing, is you're looking right into the heart of the Milky Way galaxy. So there are so many stars in the center of the Milky Way galaxy, it's unfathomable. So imagine you live on the edge of a city. You see there's skyscrapers in the distance. That's what our situation in the universe is like. We are in a big city, the Milky Way, but we live we live in the suburbs, we live in the outer boroughs. We are far away from the dazzling center. And if you live in this part of the galaxy, which is very close to the center of the galaxy, the night sky would be unbelievably bright with stars, each star brighter than Sirius and thousands of them, right? But we can see occasionally good views of the center of the galaxy, which is mostly obscured by dust clouds. So the black things you see here are dust clouds, which the galaxy is full of. They block the view, but there are little windows, and the Sagittarius star cloud is one of them. So the stars in this central part of the galaxy are around 10,000 to 12,000 years ago, 12,000 light years away. To put that in reference, that was about the time that agriculture was being developed, right? So we've had agriculture for a long time, but it was invented at one point, and that was around the time. So most of the things that we see in the night sky really dwarf human history, and so this dwarfs all of human history goes back to prehistory. If we go to the next slide, I'll just show you where it is. So it's the big circle kind of highlighted in the middle. That is the Sagittarius star cloud. Sagittarius is the tea kettle at the bottom. And it is one of the most distinctive summer constellations because it's very cute. It looks like a tea kettle. It's supposed to be an archer, but it just looks like a tea kettle. So I encourage everyone to learn where the Sagittarius is. It's in the south. And if you live here on Long Island, you have a great opportunity to go down to the ocean late at night, and you'll see it rising up out of the water. And as we go through the summer, it'll become appear earlier and earlier. And it is a classic summer constellation, and it is just full to the brim of different objects. So each of these objects that are highlighted on the chart here are really bright, beautiful clusters or nebula that you can see through binoculars or through a telescope. But if you don't have a telescope, just recommend using binoculars looking for some of these. There's one called Ptolemy's cluster, very close to the spout, which is a beautiful cluster of stars, not that far from Earth. The other things you can see, such as the Lagoon Nebula, are really beautiful through a telescope. But I'm going to switch to a different constellation now, talk about the Hercules cluster. So this is in the northern, it's in the northern part of the sky, and in summertime it's right overhead. So it's always easy for us to see. And in Hercules, there is an amazing cluster called the Hercules cluster, also known as M13 or Messier 13. So these Messier objects were discovered in the 18th century by an observer named Messier in France. In those days, you could be a great astronomer and just live in the middle of Paris, and there was no light pollution. You could see all these things through a small telescope. We're not so lucky, but we can all see Messier 13 because it's really bright. So what it is a ball of stars, like a dandelion that's gone to seed, and it is about 1 million stars in there. So our sun is maybe a little bit unusual in that it's just a single star. It's not part of a cluster that we know of. It doesn't have a companion star. But many of the stars in the universe are part of clusters and they're part of binary systems. So if you live in this cluster, the night sky would be unbelievably bright again with stars. It would be every direction you look, there would be stars that were brighter and bigger and more colorful than anything we've seen on Earth, right? However, this is very far away, and they're called globular clusters because they look like globes. This one orbits the Milky Way at about 22,000 light years distant. So for reference, the light from the star started on its way to Earth at around the same time that we on Earth were domesticating dogs. So it's also around the same time that we see the first footprints of people in the Southwest United States. So human history goes back a long ways, and in some ways we came out of a cluster like this at some point in our history in terms of our planet. Okay, if we go to the next one, you can see more what it looks like through a telescope. It is big, it is bright. Sometimes it looks like a little smudge if you're looking at it for the first time on a perfectly clear night. It is easy to find because it's part of this constellation of Hercules, which has a rectangle or a keystone. And it is, once you learn where it is, it's right in the keystone. You can actually see it with your naked eyes as the fuzzy spot of light. And the last one I'm going to talk about right now is the Virgo cluster. Now, the Virgo cluster, I mentioned is more of a spring constellation, but I'm mentioning it because if this right now, June, early July, is probably the last time of the year you can see it for a while. And the Virgo cluster is really cool because most of the stuff I've been talking to you, I've tried to make it too far away because 10,000 light years, even 1 light year is really far, much farther than anything we can actually imagine, right? The Virgo cluster is 50 million light years away. So it is not part of our galaxy, it is another galaxy, set of galaxies. And so it's not a cluster of stars, it's a cluster of individual galaxies. So all the different points of light you see here are galaxies. Now, what does that mean? Some of the galaxies, like maybe you can see a few that look like spirals, right? That are a bit like the Milky Way, but most of these galaxies are actually much bigger, much more massive than our Milky Way. And they form elliptical galaxies. So there's a trio on the right that looks a bit like a face, right? This is the whole series of galaxies right here is called Barkarian's chain. And it's fun to start in the middle from the face and work your way through them. If you go to the next one, you can see the biggest galaxy of all in the Virgo cluster. It's called M87. And if you look in here, you see a jet of light coming out. That's from a supermassive black hole at the center of this galaxy that is devouring everything that's in its surroundings. And through a mechanism which is not so well understood, it also emits an enormous jet at the poles of the black hole. And that's what we see here. This black hole is kind of famous because it was the first one photographed by people on Earth using very, very complicated techniques. But they managed to take a picture of the black hole. And so even though it is so far from Earth, 50 million light years, it's so massive that it's actually easier to take a picture of this black hole than the one that is in our galaxy. So 53 million years ago, we were in the Eocene on Earth, which is the period right after the extinction of the dinosaurs, but mammals were reclaiming the planet for themselves, which had been suddenly denuded of all the massive and charismatic dinosaurs. So this really takes me back. You can look through space and see things that are older and older. So yeah, so that's all the pictures I have for you today. There were a couple other things happening this summer that I should just mention because one is a usual thing, which is the Perseid meteor shower that happens every August, and this year will be a good one. Usually happens mid-August, like the 13th, the 14th, over a couple of nights. And it's good this time of year because the moon won't be interfering in the early morning hours, which is the best time to look for it. So if you want to see it, get up early, go out and you'll see a ton of meteors. There's also something that was in the news today. I've added to my slides because it's not something that we can see here in New York, but there will be an asteroid passing very close to Earth, I think, in a few days. And it's a very small asteroid. There's no reason to be alone because even if it hit the Earth, it would probably just blow in the atmosphere without actually hitting the planet. But there are people in the world who are going to be watching it because it's passing much closer to the Earth than the Moon is. So it'll be a cool thing to see. Every now and then, an asteroid comes pretty close to Earth, and you can see it zipping across the night sky. But yeah, that's all. So that's all I have to share with you today. But I'm happy to take any questions. And also, once it gets dark out enough, I'm happy to share my telescope and binoculars that we have, so we can see the constellations, the stars, and the galaxies, and so forth that I mentioned earlier.
I don't know if everybody knows the answer to this, but I don't know why Aurora Borealis was so visible over the what's the scientists' theories about it?
Oh, sure. Yeah. So the Aurora Borealis was caused by a really, really large sunspot on the sun. So sunspots are, if you look at the sun sometimes through filters carefully, you'll see that there are dark spots on the sun. There was a really, really large sunspot that appeared on the sun in May. And the sunspots are basically areas where the magnetic field becomes super duper strong, like it concentrates in a certain area. And sometimes what happens is that all this energy is picked up by the magnetic fields and it suddenly explodes and bursts, right? And what happens is that a lot of electrically charged particles come gushing out of the sun. It's called a solar storm. Basically, it's a cloud of charged particles, so like electrons and positrons and stuff like that come out of the sun. They travel through the solar system and they collide with our Earth's magnetic field. When they collide with our Earth's magnetic field, they tend to travel along the polar lines. So if you imagine like a magnet has like a north pole and a south pole, so does the planet Earth. And most of the time, these charged particles follow those lines and land somewhere near the Arctic or the Antarctic. And so those are the places that normally have auroras. They're basically charged particles hitting like oxygen, nitrogen, and other atoms in our atmosphere, making them illuminate different colors. Now, the solar storm in May was such a large one that the sunspots themselves were the largest sunspots anyone has seen in over 100 years. And the sunspot is still there. In fact, it keeps orbiting around the sun, and where it's back again, it's decayed a little bit. So there is still a chance we could get more auroras, but every now and then there is a really big solar storm, and it collides with Earth, and the auroras can be seen not just in the usual places, the Arctic or the Antarctic, but they can be seen all over the world. Yeah, I'm glad for anyone who got to see it. Probably a lot of people here see it. I hope people see it. I saw a lot of posts online, people from all over the world who shared it. These kinds of solar storms are really interesting. There was a really big one in the 19th century that caused a similar thing. It caused auroras all over the world. But it was so powerful, it actually knocked out telegraph lines all over Earth. To the extent that there were telegraph lines all over Earth, like 60s, they were starting to develop, right? So, but it made all the electronics on Earth that people had at the time useless because they were just like shooting off sparks. Now, extrapolate that to now, think about how much more electronic devices we have and all the international cables and things like that. If there was a similar size solar storm that hit the Earth today, it'd be problematic to say the least, right? But unfortunately, in May, we just got rid of these beautiful auroras. They were very lovely.
We have a Zoom question from Julia. Julia asks, does MTK State Parks offer night stargazing permits? Can you do an event for see it?
That's a good question. I don't know for sure on State Park whether they offer permits for stargazing. I have read in the past that they do, but you have to apply and they will before the summer. So I don't really know exactly how that works. And I don't want to speak after if they change the policy, but yeah, that's as far as I know. I'm happy to take any other questions in person or on Zoom.
Any tips on stargazing with binoculars?
Yeah, I have a couple of tips. So I brought, you stand up for a moment. I brought a pair of binoculars with me tonight that hopefully we'll try to use. And these are big ones. Yep. All right, they don't have to be so big. These are really exceptionally big binoculars. But idea is, if you want to enjoy binoculars more, they tend to wobble a lot when you use them, and you pick up the vibrations. Having some kind of tripod or monopod in this case helps stabilize some exceeds your state. And these kinds of they're like little photography tools, and they cost like $20. They help a lot when you're starting. So otherwise, other tips. The bigger the lens, the easier it'll be to see things. Yeah, just I think binocular stargazing is the best way to get into stargazing because you instantly see a lot more than you see with your naked eye, but it doesn't have the same learning curve and frustration that a telescope can have. So, sorry. Yeah.
What size would you recommend people start with size? They're home binoculars.
I think 7 by 50 is a good one. Those are pretty standard. So something smaller than that, like 10 by 30 can work too. But if it's very, sometimes they make like little ones that are only really good for like opera, bird watching, and you're like it's broad daylight. The bigger ones, the bigger the better. But the downside is that the heavier they are, the more vibrations you'll feel like it'll be harder to hold. If you really want to splurge, they also make image stabilized binoculars, which are really great, but they're probably more expensive because they have little gyroscopes inside that cancel the vibrations.
So last year we was having moisture cramps, and we were over at Hamptons. So we look up to the sky, we get pretty far, and there was this wild, like it looked like a caterpillar with lights. Like that kind of, and they went like to the sky, at the end of the sky. We've never seen that before, and they're like, "Oh, we're playing." We're like, "No, that it was a weird thing. It could have been stars, but well, you know, as a person study science, what did that have reached?" It was pretty neat. It was like bluish. It was like just bunch of like I think it was probably from like SpaceX or something. They were just setting satellites out, but that's what I think about.
Was it like a row of lights moving?
Yeah, and they went and did like a caterpillar. They got like like twisting, like a
Okay.
really wild.
I mean, I didn't see it, so I don't know. But to me, that sounds like you said, SpaceX. I think they launch a lot of satellites nowadays, and so the satellites usually look like an individual satellite looks like a complete light, like a star moving across the sky, and it usually does look like it's moving in an arc because it's moving on a curved path. However, then when they launch a bunch of them in a row, sometimes you see like a train. But that's not necessarily what it is. It could have been a lot of things. So I don't know. It's hard for me to say. I don't want to venture an opinion. But there are a lot of other things it could have been too. I mean, there are but without having seen it, I don't know. But it's great that you were out there.
Yeah, pretty wild.
Did you see what were the horseshoe crabs up to?
Yeah, well, we tagged them.
Oh.
They were
Wow.
there were a lot of them made. They were made on.
Yeah.
We tagged them and so that they can find them.
Was it during the full moon?
Yes.
Oh yeah,
Yeah,
that's
so
what
that's what they do. Right. Whatever, they're pretty neat. It was enjoyed it.
Awesome.
Yeah.
Yes.
Do you know any apps where you're going like when you pointed at the sky and that you find out what's up there?
Yeah, there's a lot of apps that do that. I use one called Sky Safari. There's others.
We use Skyview.
Skyview. Okay. Honestly, it's just a matter of preference. There's so many nowadays that you can just go in the app store and try it out. And some of them, like if you have a phone, then sometimes you can actually just point it and it'll show you what the name of the constellation is. That's a good bet. And then yeah, there are other apps that you can use that are like more detailed. So they're really good if you have a telescope because you can like so refer, but I used to go out in the night sky with these huge charts that were laminated. Which were fun, but they were so inconvenient, like you have to have a red flashlight to shine on the chart, it's like in the days before. Smartphones, but nowadays it's definitely a lot easier with an app to find. Maybe we can take one more question if there's anything online or. All right, well, thank you all for coming out and please stay.
Yeah, thank you.
We're going outside now.